Hey there folks, Mr. G here with another educational video. This time we're going to follow up on what we talked about last time, where we spoke about KMT, the kinetic molecular theory, and a little bit about how it explains the different states of matter. Today we're going to follow that up by talking about how it explains the changes of state, so how we go from liquids to solids to gases. But first, don't forget to put your name on this, Day 2, Period 1, today is December 10th, and this is page 8. So we've got our three different states, solids, liquids, and gases, and matter can change between solid, liquid, and gas states. And that means there are 6 types of phase changes. Basically, everyone going from solid to liquid, liquid to solid, solid to gas, gas to solid, and gas to liquid, liquid to gas. So, from solid to liquid, we call that melting, and the other way is freezing. So think about melting water or ice into water, and then freezing water into ice. Going from liquid to gas, we call that vaporization or evaporation or boiling. So you've probably seen this. If you leave water on the counter, some of it will evaporate away. That'll turn into gas. Or if you boil water, right, that's also making water into a gas. Going the other way is called condensation. So maybe you've seen that on windshields, or maybe you've had some condensation on a drink before. That's where a gas goes into a liquid. Now, a little bit less common are when we go straight from solids to gases or gases to solids. This doesn't happen with water, but it does happen with other materials. For instance, dry ice is carbon dioxide. Carbon dioxide is usually a gas, right? That's the gas that we breathe out of our lungs. But if you get it cold enough, it doesn't actually turn into a liquid, it turns straight into a solid. So when it goes straight from gas to solid, we call that deposition, and straight from solid to a gas, sublimation. Now, how can we understand these changes of state using kinetic molecular theory? Well, when matter changes state, it's because kinetic energy is added or removed. So we're going from states with high kinetic energy to lower kinetic energy, or in the other direction. And temperature is the measure of the average kinetic energy. So if our temperature decreases, the particles have less kinetic energy, they move slower, and the same in reverse. If we heat something up, they increase their kinetic energy and move faster. And if you do this enough, you can go from a state where all of our particles are moving in a certain way to moving in a different way because their kinetic energy increases beyond a certain point. Melting and boiling points are the unique temperatures that an entire sample of the substance will change state. So this is where all of the liquid, say in water, when you boil it, all the liquid will start to turn into a gas. Now you might wonder why we talk about melting and boiling points and not condensation or freezing points. Well, condensation and boiling point, right? The temperature where this transition happens is the same in either direction. You can either call this the condensation point, gas to liquid, or the boiling point, liquid to gas. Those are the same thing. Same with freezing and melting. So it's the same temperature where this transition takes place. So you could call them this, they're just less common. Here we're told that the melting point of mercury is negative 38 and its boiling point is 356.7. So what state would it be at room temperature? Since we know that its melting point is negative 38.9 degrees Celsius, that tells us the transition from liquid to solid happens at this temperature. And the transition from liquid to gas happens at this temperature. Since we're in between, it has to be a liquid, because 20 degrees is bigger than the melting point, but lower than the boiling point. So it's melted, but it hasn't boiled yet. So KMT explains why a substance changes state when it's cooled or heated enough. So we can use KMT to explain the changes in the motion, the attraction, and the distance between our particles. So when we're melting something, our particles start to move faster. We're heating them, they're going from a solid to a liquid, so they're going to be moving faster, and now they can partially overcome the attraction. Instead of being stuck next to each other like this, just vibrating, now there's enough motion, there's enough energy that they're not stuck together, vibrating. They can move and flow past one another. And the distance between the particles gets bigger because there's less attraction. They move farther apart, and now instead of being all stuck together in a certain shape and holding their shape, now they can move farther apart and take up the shape of the whole container. Vaporization, so that's like boiling. So now we're heating the particles to make them move even faster. And now they can completely overcome the attraction. So now when we go from a liquid to a gas, instead of just flowing past one another, now they can just move in all sorts of different directions. There's not that same attraction to the other particles in the liquid. So they can completely overcome the attraction, and with basically no attraction, they can move far apart. So they can escape into the surrounding air, and they can fill up the whole volume of whatever container that they're in. Now I'm going to put some visualizations of this, some videos. Hopefully this will help you understand exactly how these transitions take place. But one thing I'd like you to think about right now, obviously we're not in school for this because of COVID, but in your group, imagine what you would do to model your assigned change of state. So whether you want to think of it as melting, going from solid to liquid, or vaporization from liquid to gas, or even in reverse, going from gas to liquid or liquid to solid. So you might want to look at page 141. There's some good visualizations here. And imagine you were doing this with a couple of people, where each person represented a particle. So maybe think about 5 or 10 people and think about what would change. You can write down a description if you like, or just imagine in your mind. If you'd rather do it in your mind with like plastic balls or something like that, that might be a helpful way to think about this and consider the movement, attraction, and the distance. That's the end of our video here. Make sure you try out some of these practice questions at the bottom here. The answers are available on Teams, as well as any of the other practice, other videos, or anything else in the homework section for our post for today. Thank you all for tuning in, and I'll see you all in the next video.